Hello, somebody is asking a question. A cube has edges of length 1, so it's a cube here uh, of length 1, and is a dot marked in the center on the top face, and it's sitting on a flat table. Now, the cube is rolled without lifting or slipping in one direction, so at least two of its vertices are always touching the table, so it's rotated around here. So what's happened now is the next time it rotates, you can imagine it kind of is rotated along at this point, and it's going, the dot's going to be here, and then it's rotated again. So the dot is kind of, the next time the dot will be at the bottom here, and the last time again, it's going to be on this side, and then finally you rotate it one more time and it returns back right here. So it's kind of moving from here to here, and then from here it's going down, and from here it's going up, and from here it's going like this. And we are asked to find the length in centimeters of the path traveled by the dot. So the answer is here. The answer is this one. The answer is right here. We look at this diagram here. So this is the first, the original position, and you can see it's rotated along this point. Okay, it's kind of going around, and it's resting. This piece here, this length, this surface is now actually, this surface on this rotation is happening here. So you can imagine all you got to do is you find the length of this point, and it's a quarter of a circle, and the length over here is going to be, this is side 1, so this is going to be side half, and by using Pythagoras you're going to get 1 squared plus 1 by 2 squared, and that's going to be this side. So this, you can call it r squared. So you can see that r is going to be 1 plus 1 by 4. R squared is going to be 1 plus 1 by 4, so it's 5 by 4. And so r is going to be square root of 5 divided by 2. And that's, so you can see this particular part, you can see the symmetry here. It's going to be rotated along 90 degrees, and I leave it with you to prove that it's actually 90 degrees. And if it's a 90-degree thing, we know that if it's rotated at 360 degrees, that's 2 pi r. So it's actually going to be 1/4 of 2 pi r. Okay, and r being this side, this radius. So actually it's just going to be pi by 2r. And you can see this is the distance which is rolled. And now we come to this next point here, and the point around which the cube is going to be rotated is here. So it's going to be kind of going down, and all you got to do is find this radius, and that radius is, let's call it r2, and that is going to be just a ½ centimeter. So the distance traveled is going to be 1/4 of 2 pi r2, and that's going to be 1/4 of, or rather it's going to be, let's just say we just cancel this out, and you're going to get pi by 2 r2. Okay, so this one is pi by 2 r, and r is right here, so r is right here, and pi by 2 r2, and r2 is right here. And now you can see there's a nice symmetry here. Then the third time it rotates, it's going to rotate around this point, and it's going to go in this direction. It's exactly half, so it's going to be, again, going to be this distance. And the fourth time it's going to rotate around this one, so you can see it's exactly this distance, half and 1. So use the same distance, and it's going to rotate 90 degrees. So we're going to have 4 distances, 4 quarter circles. The first one is going to be pi by 2 r. Second one is going to be, this one is going to be pi by 2 r2. The third one's going to be pi by 2 r2 again, and that's the red one. And then the blue one is going to be pi by 2 r again. And so that reduces to pi by 2 r, and r, these are the same. So you're basically going to get pi r here, and then this and this combined. So you're going to get pi r2 here. And you already know what is r and r2. R is right here, so you got pi, times square root of 5 by 2. And then you've got R2, which is half, and that's here. And then you can just factorize it or bring out the half, and you've got square root of 5 plus 1, and that's what you need.